Hi, everyone, and welcome to Module 2 of Introduction to Artificial Intelligence with Machine Learning. Today, we are going to be introduced to machine learning. In the previous module, we focused on understanding artificial intelligence, what it is, and how it fits into the real world. And in this module, we're going to focus on the mechanism that actually makes modern AI systems work, which is machine learning. My name is Nihika Singh, and I will be your instructor for this course. Machine learning is not just a tool, it is the dominant paradigm in AI today. By the end of this module, you should be able to clearly define machine learning, distinguish it from traditional programming, and understand why it is a preferred approach for solving complex problems. We're also going to introduce some foundational terminology that you will keep using throughout the rest of your course. Now, when people first hear the term machine learning, they often think of something that's beyond comprehension and very complex, but machine learning is much more grounded than you think. It is a statistical and computational approach to problem solving. At its core, machine learning is about using data to approximate a function. A function in this context is mapping from input to output. For example, given information about house, the function maps those inputs to a predicted price. So instead of thinking of machine learning as intelligence, it's more accurate to think of it as function approximation using data. This shift in perspective is important because it grounds machine learning in mathematics rather than imagination. It's not trying to replicate human thought, it's trying to produce accurate outputs based on patterns in data. Let's now define machine learning more formally. Machine learning is a subset of artificial intelligence that focuses on algorithms that improve automatically through experience. An algorithm is a set of rules or steps used to solve a problem. Experience refers to data, specifically, data that the system uses to learn the patterns. So, when we say a system learns, we mean that its performance on a task improves as it processes more data. Another important term here is model. Model is the mathematical representation that the system uses to make predictions. So, machine learning can be understood as the process of training a model using data so that it can make accurate predictions or decisions. To understand why machine learning is so important, we need to compare it with traditional programming. In traditional programming, we explicitly define rules. We provide input data and rules, and the system produces an output. In machine learning, we reverse this process. We provide the input data and the correct outputs, and the system learns the rules itself. This is what we call supervised learning, which we'll explore more in detail later. The key idea here is that machine learning systems infer patterns rather than being told exactly what to do. This makes them much more flexible and scalable compared to rule based systems. Now, the reason why we can't just write rules or why machine learning is necessary is because many real world problems are too complex for rule based approaches or traditional programming approaches. These problems often involve high dimensional data. High dimensional data refers to data with many variables or features. For example, an image has thousands or even millions of pixels, each representing a variable. Writing rules for such data is practically impossible. Additionally, real world data is often noisy and unpredictable. Noise refers to random variation or errors in data. Machine learning systems are designed to handle this noise and complexity by identifying patterns that are statistically significant rather than relying on rigid rules. To make machine learning precise, we use a formal definition of learning. A system is set to learn if its performance on a task improves with experience. You may be getting a flashback to our very first module, and if you haven't watched that yet, go back and watch it right now. This is broken down into three components: task, experience, and performance. The task is what the system is trying to achieve, the experience is the data set used for training, and the performance is measured using a metric, such as accuracy or error. A metric is a quantitative measure used to evaluate performance. This definition is important because it allows us to evaluate learning objectively. A critical concept in machine learning is the difference between learning and memorization. Memorization means storing data exactly as it is. Learning, on the other hand, means identifying patterns that generalize beyond the training data. Generalization refers to the ability of a model to perform well on new, unseen data. Basically, when a model is trained, it makes a generalization about unseen data. A model that memorizes data would perform well on training data but poorly on new data. This is known as overfitting. Overfitting occurs when a model learns noise instead of patterns. You can think of it as overly training a model on one specific training data set such that it is designed accurately for only that specific data set and it is unable to make generalizations. So the goal of machine learning is not to store data but to learn meaningful patterns that generalize. Machine learning is widely used in real world applications. Search engines use it to rank results based on relevance, recommendation systems use it to suggest content based on user behavior, voice assistants use it to convert speech into text, and these systems rely on trained models that have learned from large data sets. A dataset is a structured collection of data used for training. These examples show how machine learning is applied in practical contexts to improve user experience and decision making. One of the key advantages of machine learning is adaptability. Adaptability refers to the ability of a system to update its behavior based on new data or adapt to new rules and situations. In dynamic environments, patterns can change over time. Machine learning systems can retrain on new data to stay relevant. This process is often referred to as continuous learning or model updating. This makes machine learning systems more robust compared to static rule based systems or traditional programming. Machine learning is particularly effective for solving complex problems. Complexity arises when relationships between variables are nonlinear. A nonlinear relationship means that changes in input do not produce proportional changes in output or similar changes in output. Traditional models struggle with such relationships. Machine learning models, especially advanced ones like neural networks, which we will get into later, can approximate these complex relationships. This ability to model complexity is one of the main reasons machine learning is so powerful. Now, machine learning is closely related to data mining or learning from data. Data mining refers to the process of extracting useful information from large data sets. Machine learning automates this process by identifying patterns and trends. This is particularly useful in decision making. For example, businesses use machine learning to analyze customer behavior and optimize strategies. So, machine learning is not just about prediction, it's about discovering insights from data. Let's define some key terms that are used frequently in machine learning. A training set is the data set used to train a model. A training instance is a single example within that data set. A feature is an individual input variable used by the model. For example, in a house price model, size and location are features. These terms are fundamental because they define how data is structured and used in machine learning. Now, to summarize this module, machine learning is a data driven approach to building intelligent systems. It replaces rule based programming with pattern recognition. Learning is defined as measurable improvement over time, just like before. The goal is generalization, not memorization. And machine learning enables systems to handle complexity and adapt to change. In the next module, we'll go deeper into how machines actually learn, including models, parameters, and optimization techniques. I am very excited to be conducting this course as the Leadership and Innovation Ambassador for the Innovation Hub. If you're someone who wants to create and collaborate in STEM with like minded peers, I would highly recommend you to join. Thank you for watching, and I am looking forward to seeing you in the next module.